Hello and welcome. I'm Umberto from Rive. I'm a software engineer. And today we'll be looking at how to draw widgets and build custom behavior in Flutter and also with Rive. So what is Rive? You might know Rive as Flare. Before we were called Flare, but now we've rebranded everything as Rive. Rive has announced a seed funding stage round from A16Z last month. And for those of you who weren't familiar with Flare at all, Flare is a real-time interactive design tool that allows you to build custom animations. We have a web editor that you can use to export animations and run it through our open source runtimes. We have a number of runtimes, one in JavaScript with a React counterpart. There's a Swift runtime that is running on macOS and iOS, and there's also, of course, a Flutter runtime, which is our most popular runtime. It's gotten more than 1,700 stars on GitHub, and all of these runtimes are open source, so you're going to be, if you want to take a peek and help us out and figure out problems that you might encounter, please do. Our journey as Rive, or before that as 2 Dimensions, with Flutter began a couple of years back. We started working with Flutter for IO18. We built the Flutter Hot Reload game at IO18, and for those of you who were there, you might have seen us screaming next to the Flutter tent, trying to garner your attention. Then we built, later that same year, the History of Everything up for Flutter Live, and that was downloaded more than 1,100 times on the Play Store, and it's also available on the App Store as well, of course. Last year at Google I/O19, we built a developer quest, which was used as an example for a number of Flutter talks. And last month at Flutter Interact, Tim Snead presented on stage the Dash demo that was built by our team. So what about today? Today we're going to take an overview of what Flutter does for rendering. So we're going to be looking at CustomPaint, the Flutter trees, how Flutter trees are used to be efficient, render objects, and the RenderBox. Later, I want to take you through a number of things that we use in Rive for painting, our runtime, and especially Flare RenderBox, what are animations and controllers. So how does Flutter render? It happens in 4 stages. There's a layout phase in which the primitives are gotten and widgets are placed on the screen and their sizes are computed. Then the framework will pass a canvas object to those widgets and will tell the widgets to paint themselves on it. Later, the Flutter tree structure will try to build a number of layers so that the widgets will know which layer to be on, and then those layers are going to be composited and the pixels sent to the GPU for rasterization. So for example, if we are in the layout phase, constraints are going to be passed down the tree, and there's a tree structure for all the tree. You might have built widget tree structures in your app, of course, and constraints are going to be passed down, and once the tree is going to be explored down, the widgets are going to be passing up their sizes, and after that we paint. So let's take a look at CustomPaint. CustomPaint is a widget, and the idea, as we saw in the painting phase, is to access the canvas. If we can get access to the canvas, then we can perform drawing operations. And how does CustomPaint do that? Well, it's a widget, so you can put it in your tree. But then, as a parameter, you can give it a custom painter. Custom painter is an interface that you can implement with a class, and you can override the paint method to be able to access the canvas and perform your drawing operations. Flutter, as you might know, uses Skia as its rendering engine. So all the primitives that you see for accessing the canvas and all the methods that are on the canvas are obtained through Skia, and this is their Flutter's rendering engine. It's a C++ open source engine owned by Google, and it's a pretty impressive engine. So if you want to take a look at that too, I encourage you to do so. CustomPaint is very plug and play. It's very easy to use, and I want to show you a little example that I built. Let's see if we can get it on screen. So, wait, we gotta exit this. And I can show you There you go. So this is an easy, sorry guys. So we got a main. This is the simple app that you'd get from using Flutter Create. And as you can see, there's a CustomPaint widget in the tree. So this is part of the tree structure. There's a center. We're going to see a circle painter, and that's an implementation of the custom painter. And this is just going to display a circle on screen. So if we go to the right folder and we Flutter run this, you can see the widget on screen. Let me get there. Okay, so what is Circle Painter? As you can see, that's a wonderful circle in the middle of the screen. But Circle Painter is an extension of Custom Painter. And what I want to show you is that if you override the paint method, you get access to the canvas object and a size, because the widget has got to have its size. And what's relevant here is the draw circle call. This is what draws the circle on the screen. You got to give it a position, so we calculate the offset from the center to get to the center of this widget. And then we got to give it a fill. So this is the way that the circle is going to be painted on the screen. So this is fairly simple. And as you can see, you can do all kinds of crazy things because Canvas gives you access to a lot of primitives, a lot of methods. So let's get back to the presentation, and I can go through what Flutter does with its multiple trees. So there are 3 tree structures that are used by Flutter. The first one is the widget tree structure, which you might have seen and you might have built using your apps, creating your apps. And this is, the widgets are responsible for creating and updating elements and render objects. I think Robert or Norbert might have explained this yesterday morning if you were at that talk. Elements, on the other hand, are efficient at comparing objects. So they're meant to be something that sits in between what widgets do and what render objects do. And what do render objects do? They are responsible for laying out elements for painting and for hit testing. So let's say that you have a simple text widget on screen and you want to replace the text that sits in that text widget with a new text. Instead of rebuilding every time all the various trees, Flutter tries to be as efficient as possible. So the widgets can be, being lightweight and immutable, can be replaced really quickly. So the widget is going to be rebuilt from scratch. But the render objects, which are responsible for rendering, which are heavier and mutable, we want to keep them there. So the text in the text widget that you have in your widget tree is going to be replaced. The widget is going to be recreated. But the render objects that's underlying that structure is just going to be updated with a new set of parameters. So we've seen what render objects are, and render objects are responsible for laying out, again, painting, etc. And they're a pretty abstract concept. So Flutter provides another implementation of render objects, which is a RenderBox. And it's a render object in a 2D Cartesian coordinate system. So the origin of a RenderBox sits at the top left corner of the widget, or the render object, as you may, and it's given a width and a height. If you want to create a new semantic model for laying out, for painting, for hit testing, you can subclass it and define your own things. And it's used by a runtime too. So I wanted to show you, I prepared also an example for how you can create a RenderBox and extend it to implement it in your own app. So we get started from the idea that you first need to have a widget in your tree, right? So in order to be able to do that, you need to create something like a circle render object widget. We're going to be creating exactly the same app as before with a circle rendering in the middle of the screen. But again, we need to place a widget in the tree. So first of all, you got to extend a leaf render object widget that, as Norbert mentioned yesterday, is a widget that doesn't have any children. And this, as I mentioned earlier, is responsible for creating the render object. So you override the create render object method, and you make it return the render object or the render box that's going to be responsible for rendering the circle on screen. So over here, we got the circle render box that extends a render box. And as you can see, we override a bunch of things. Well, we gotta be telling it that it's sized by its parent, so that it knows its size. The hit test self is gonna return true because we want it to be responding to hit test events. And what's relevant here is the paint call. The paint call, this time around, doesn't have a canvas object as its parameter, but it's got a context. But we can solve this pretty easily because the context has got a canvas field, and we can extract that. Then from the size, because size is a field in the render box, it knows its size, we can get its width and its height. And at the bottom of the call, of the method, we can see that there's exactly the same call as before. So we gotta draw the circle, we give it an offset, but this time around, instead of the offset within the widget, we gotta give it an offset globally from the screen, and we compute that through the offset parameter that's given through the paint call in the render box method. And then we give it a radius, a size basically, and a fill paint, which is exactly the same one as before. So if we go inside the folder and we run it, hopefully we'll see the same object as before. And again, as you see, this is fairly simple. You create a leaf render object widget, and then that render object widget gives you access to the possibility of creating a render object. So as you saw, hopefully that was correct. You saw the orange circle on the screen, and everything came together. So for those of you, again, not familiar with Rive, Rive is an editor. It allows you to build animations. And I want to go through a couple of concepts here, basic concepts. You might see the animation on screen, and you can switch in the editor between a design mode and an animate mode. In design mode, you can build your hierarchy, and that hierarchy is going to be your objects, and you can add objects such as circles, rectangles, vector shapes, but also raster images. You can perform vertex deformations on those shapes. And in order to animate those objects, you switch to animate mode. You're gonna see a timeline pop up, and you can set keys in your animations to, let's say, move around an object, change its scale, change its vertex deform, and so on. So those objects, those concepts, the artboard, oh, I missed the artboards. The artboards are the top containers for your hierarchy. And the artboards and the animations are gonna have counterparts within our Flutter package, which is our runtime. And those are gonna be actor artboard and actor animation, of course. So we saw with the render object that if we want to place something in our widget tree, we need to have a widget. And this is what Flutter provides. We got a Flare actor, which is a widget that loads a Flare file. A Flare file is a file that you export from the Rive editor. And once you get that in place, you can place it in your widget tree like this. You give it a path. You gotta import your assets, put those in your pub/spec YAML, of course. And you can play your animation simply by giving it the name of the animation. The name of the animation, it's gotta be compliant with what you created within the Rive editor. But you can also control your animation by using a custom controller. And we're gonna see how that works later in this talk. So just to give you an overview of the object structure, we've seen the render object, and we've seen that the render object gets extended by the render box, which is less abstracted. And we're going to use an extension of RenderBox exactly as in the example before, which is the Flare RenderBox. In our runtimes, if you peek through the code, you're going to see that the Flare RenderBox is an abstract class that's responsible for displaying displaying the Flare file and also advancing the animation. So this is what's scheduled scheduling a transient frame callback, which is a callback that's called every frame, and it gets the animation running. But being an abstract concept, it provides the painting call, so you're going to see the painting implemented in there, but it advances frames, but the concrete implementation, the final concrete implementation of everything is in Flare Actor Render Object, which is an extension of Flare RenderBox, and it fulfills the advance call. So again, you get a leaf render object widget, and in this case, our Flare Actor is an extension of that, and that creates the render object. In our case, the Flare Actor will create the Flare Actor render object, and this is what renders everything on screen, the animations that you see in the editor. So lastly, let's go through the controllers. The controllers are an interface that the Flare Flutter package provides, and you can extend it or mix it in to implement custom operations. How do you do that? Well, there's an API. First of all, you want to tell the framework if the controller is active. If it is active, then the framework will continue advancing the controller, and it will continue providing the operations that you've implemented. Then there are three methods. First, initialize, which lets you fetch information about the current state of the hierarchy. So your Flare file will have its hierarchy inside, and you can fetch references to nodes and stuff like that, or references to animations, actor animations, for example. Then there's a set view transform call, and for those of you in the crowd who are a bit familiar with the graphical engines, in this call, which gets called every time that the controller actually is advancing, so when the controller is active, we're going to relay the view transform so that we can move from one transform space to another. And then there's an advance call. You got to return true in the advance call if you want the controller to still be and understood as being active. And in here, you're going to perform the advancing functions of your animation. So let's see a bit about how this can work. So we've seen the render object, we've seen the various parts of this, and then let's get to the controller. Sorry, there's a bit of delay with the mouse, so it's not super easy. All right. So again, we start with a Flutter create project. It's fairly simple. There's a really simple build call. And as you can see here, there's a Flare Actor widget with the Flare file, and we're giving it an animation. So this is going to play the walk animation. So let's go to controller and Flutter run this. And we're going to use Flutter hot reload to see how we can improve on its behaviors. So this is one of our examples. If you go to the Flare Flutter GitHub page, you can see in the examples folder a way we've implemented a controller to make this walk around. So this is fairly simple. We're just playing back an animation, and you see a penguin walking. But what if you want to actually do something stranger with the penguin? A penguin is a fun element, so we want it to be doing strange movements. So we reload, and you can see that now the walking phase of this penguin is sinusoidal. I've implemented a simple algorithm in here in which we use the sine of the time, basically, to make it walk fast and really slow. So you can see that the animation is controllable at runtime. So let's go through an example that's a bit more fun. You've all seen Philip, the Google DevRel, from the Google DevRel team, and we got a wonderful Philip animation here, and it's been labeled as our mascot for Rive. And you can see Philip dancing around, throwing his phone up in the air and catching it again. But what if this is too simple again, and we want to use a custom controller? Well, I've decided that I want Philip to do this on an infinite loop, but back and forth. So instead of giving it the animation name, we're going to play and revert the animation. So it's going to play once forward, is throwing his phone in the air, and then it's going to play backwards. So we're going to see it do some crazy magic here. And this is an example of a controller. It's going to play, obviously, infinitely. But this is not just it. I wanted to show you one last example, which might make you understand even more the idea of what I mean by modifying the hierarchy in Rive. So this is the Rive editor that I've shown you before in one of the slides. And this is on the left, yeah, on your left, you're going to see the hierarchy. And take a look at the name of the nodes. The node that we're going to be controlling is this look node, which is a node that allows you to make this guy look around. So we got a lost spaceman who doesn't know where to look. And what we can do is move to the last demo. And if you're a bit familiar with linear algebra, this is going to be easier to understand, and all of this code is going to be available on GitHub. So again, Flutter create project, really simple. We got a gesture detector, and we include the space flare file, and we pass in a space controller. So let's go to the space controller demo and Flutter run this. How this shows the power of Rive is in the fact that you can actually manipulate that node at runtime. So anything you see in the flare hierarchy can be manipulated. And this is awesome. Wait, I've got the example on my screen so you can't see it. And you can see that the animation is playing. There's an idle animation in the background. You can see his arms moving. But what's more interesting is that you can look around in real time. And this is not a video playing. This is not like a video playing. You can move stuff around, take a look around. There's your dead companion over here. Sadly, he didn't make it. And this is all moving in real time, right? So you can control, by just controlling that single node in the hierarchy, you're achieving a complete manipulation of the visualization on screen. And this is amazing because your designers can have all sorts of ideas, and this is exactly our goal, to simplify the designer-developer interaction. So developers will have all sorts of crazy ideas, and they'll be responsible for building all the sorts of crazy math in there, but your designers can have the possibility of creating amazing animations. And those two elements in your software house are going to be able to work together seamlessly instead of having to recreate everything from scratch from one platform to the other. And as you can see, the representation of the flare file is exactly the same as the one as you saw in the editor. And so this is it. This is our walk through the flare and the Rive collaboration. So if you want to reach out and you have any questions, feel free to ask them now, or we have Twitter, we have email. Talk to us and let us know what your thoughts are.
Hello.
Hi.
Thank you for your talk. I want to say I'm a newbie on Flutter. I'm programming for a year now. And I was also interested in Rive. And I was looking for tutorials on the internet. And I found one tutorial from a beer. And I was asking, and perhaps I missed it, is it somewhere else, but are there more tutorials to learn Rive?
Sorry, I didn't catch the question. Could you repeat it again?
Are there more tutorials on the internet to learn Rive?
Yeah, we're working on that with our design team. We know that we're lacking on that regard, and we're trying to do the best effort we can to fulfill that gap. And do you need tutorials for creation, for design, or do you need tutorials for using the API?
Both.
Both.
Yeah.
Okay, sweet. Okay, because we have a number of Medium articles about using the Flutter API, and again, we know that we got to do better. We absolutely know this, and we're trying to put the best effort we can. But those will be coming. More tutorials. Well, I've heard you at the booth saying that you need 0 to hero kind of tutorials for Rive. We want to get them out there at some point in the near future.
Yeah, and start with simple, short tutorials. Because the beer is a very good one, but it takes about 2 hours or something. I don't know exactly, but I stopped it, and I was looking for simple.
Right, yeah. And one thing that I can suggest, I've seen, there's this guy called Mark Thompson, is an active Flutter member of the community, and he's been doing 100 days of Rive, and he started from scratch. His first image is just a radial gradient, a circle with a radial gradient, and he's slowly, well, quickly becoming really good at building simple interactions in Rive. So if you want to go and take a look at his profile on Twitter, you might be able to find some interesting stuff in there.
Oh, thank you. Good tip.
Oh, you're welcome.
Yeah.
But I know that we need to do better with the tutorials. We will for sure.
Okay. Thank you.
You're welcome.
Over here. To your right. Oh, yeah. Yeah.
Oh, there.
Yeah, thank you. Thanks for your talk. Very impressive animations and possibilities. And obviously, when you are implementing like animations or fancy stuff in your app, as soon as it gets very intricate and complicated, you think like, okay, the performance must go down somewhere. So what are the limits? How is Rive doing performance-wise on Flutter apps? Is there something like, okay, if the number of elements in the Rive editor is getting too high, slower phones can't deal with it. Like, what experience do you have there?
Well, so we've seen that the performance is generally really good, mostly because Skia does a great job at rendering. So we try to be as efficient as possible, just as Flutter does. So we render at VSync, so we try to render every frame as fast as possible. Then there are some concerns. If you use huge images, the fill rate of the GPU is obviously going to have problems. If you have a lot of really tiny small elements in the backgrounds, if you create a sky filled with stars, obviously the rendering engine will have to render, I don't know, thousands of small dots. That's going to take a hit on performance. But in general, we try to be as efficient as possible. You'd need to talk with your artists generally and try to be smart in what you do. If you have a background with the sky, maybe try to use an image instead and try to be smart about which resolutions you're going to be using. Instead of using a 4K image, you might use a full HD image, and that's going to be enough maybe on all screens. So be mindful of this, but in general, your Rive hierarchies should be rendering at full speed, hopefully.
Okay, thank you.
You're welcome.
Okay, another question. Thank you for the presentation. It's great. And question here, you generate Flare file.
What, sorry?
You generate Flare file with the editor of yours, but is it possible to import from other, like After Effects, for example, or something like this? So the designers use the tools they prefer and just import to Flare. Is it possible?
Well, right now we have a workaround. Obviously, if you have an After Effects, if you're building a new animation and you have Rive and After Effects, we hope that you're going to start building your animation in Rive instead. But if you have a lot of After Effects animations, you might have heard of Lottie, which is a tool used by created, I think, by Airbnb. And we have worked with Hernan Torrisi, which is the creator of Body Move-In, the plugin that allows you to export to Lottie. And there's a Lottie to Flare converter right now in place. It's an open source package on GitHub. And what you can do is use Body Move-In, create a Lottie file, and then drag and drop that file into the Flare editor. And it should, unless there's some miscompatibility with some features, because After Effects has got a million features and we're missing some of them, it should be fairly compatible. So you can just try that.
Yeah, but this Lottie sounds perfect, so thanks a lot.
Okay, awesome.
Hello, thank you for your talk, it was amazing. And in the space controller demo, there was a small element, a nut, which was just rotating in 360 degrees.
Oh yeah.
I'm just wondering, what sort of black magic is that? Because it's obviously 2D.
What sort of what?
Black magic.
Well, that's all on our artist, JC Toon. You might have seen his work if you followed us a little bit. He's done the robot that you saw in the first slide. He's done a number of other artist work. And also, by the way, our website, Rive.app, has got all of this stuff open to the public. So most of JC Toon's files are forkable. You can go on the website, fork them to your own files. If you create a profile on Rive.app, you can import them into your own files, and if you need to learn how, for example, JC Toon achieved that simple rotation, you can take a look at that directly yourself and learn from that. So we know the tutorials are still missing, but there's an open design initiative in there. There's an open design mentality where you can learn directly from the artists. So I don't know if I answered your question.
Yes, thank you.
You're welcome.
So thank you for your talk, it was great. So I have a question about, do you think it would be ever possible to have widgets inserted into the Rive animations? For instance, when you showed us the Philip animation, jumping with the phone, I was wondering if it would be ever possible to insert some Flutter widget into this animation.
I know that we've been used. Our Flare actor has been used with a number of other widgets, with opaque as a hero widget and so on. But inserting a widget within a Flare hierarchy, I don't think that's currently possible. You'd need to, well, you can do some hierarchy manipulation with the controllers. So if you want to create nodes or swap in, for example, there's a thing called the solo node, which is a node that allows you to decide which child is going to be visible in the next frame. So for example, if you have an eye and you want it to be open or closed one frame to the next, you can switch between its solo children. But we hope that you use Rive to build those things. If you have some strange thing that you want to pop in and out, we hope that you use Rive for that. So,
thanks.
Yeah. Not at the moment, I'm sorry. Welcome.
Hi, great talk. It's not a Flutter question, but I'm interested in how the Rive.app app actually works. Is it with WebAssembly or?
Do you mean the editor that you saw?
Yeah.
So yeah, it's well, it's not WebAssembly. It is using CanvasKit, which is a web-assembled version of Skia. So it's Skia, the engine that runs Flutter. Again, it's an open source C++ engine, and on their website they provide some ideas on how to build it. So yeah, it's you use mscript and you build it. And you can run the WASM version of the engine. So it's still using a GL context underneath. Because it's attaching to that to perform rendering, but it's using Skia primitives, and this is why actually our faithfulness is so good between the editor and Flutter, because the engine underneath is exactly the same.
Yeah, thanks.
So so if I import animations in Flutter, does it have other extension points, not controllers, but maybe to insert your own render boxes or your own CustomPaint algorithms?
Sorry, I didn't understand the question. Can you say it again?
So which other extension points are there for painting, like for example, render box items which you insert from the Flutter app yourself, like not from the Rive editor, but from the application logic?
All right, I'm not. We can talk about that later, maybe. Okay. Sorry, I didn't.
Hi, thanks for your work. I haven't used Rive any yet, but maybe it's some dumb question, but I'm interested when I download some file, Rive file, can I get the list of animations maybe from it, or I have to read the documentation for this file to get to know which kind of animations it can be played?
Or do you mean in code with the API?
I just found some Rive file, without any information about this.
Yep.
And how can I know the kind of animation it can be played?
Right, yeah. Well, there's a way, you can access the actor animation. So the artboard is the container of the hierarchy, and this is an actor artboard in the Flare Flutter package. Once you get access to that, and you should because you're accessing the file itself, you can grab access to you can list those animations and print their names if you don't know what their names are. So you should be able to get there, absolutely. Otherwise, you can try to import, if you've got there's two modes of exporting in Rive. There's an exporting a Flare file, and then there's, you can download a copy of your own file, so as a backup copy. If you download that, then you can import that in the editor and see what the animations names are. But otherwise, through the API, you can definitely get the names of the animations. And by the way, this is absolutely not a dumb question. There are no dumb questions.
Thank you.
You're welcome.
Thanks. And so my question is, how does the Flare file looks like? Is it some binary format or XML or something?
All right, well, there are actually two formats. I can show you. Sorry. If you click here, you go export. You can choose between downloading a binary file, which is our most supported and compressed version of the Flare file. So obviously being binary, it's super efficient. And there's a JSON format. So JSON format is going to be human readable. You can peek through how we build the hierarchy in the file, and that is exactly what you see imported in Flare Flutter. And if you want to make small tweaks, JSON is perfect for that. So you can use JSON to read what you're actually building, and use binary in production maybe if you want to be more efficient. It's going to be faster at loading, of course.
So, and I can manipulate the JSON by manually and adjust some content of this file?
Absolutely, you can, because what's been read in the file is what's been reproduced in the runtime. We don't encourage you to change up the whole hierarchy structure in the JSON file. I think that that's going to lead to some pretty bad results. Do it in the editor, but if you want to see if a color is better rather than the one that you already created, instead of having to go to the editor and change it up again and export it again, you can simply do those kinds of things. You want to change a scale, maybe you want to see if an object scale. So simple things, you can definitely do it. You can also do hierarchy manipulation, but then if something breaks, it's up to you. Keep a backup copy or export it again.
Thanks.
You're welcome.
Hi. How does a Rive animation handle its scale? Let's say I wanted to build an asset like a switch or anything, it's a fixed scale. Does it scale to the dimensions of the container or that's surrounding it, or does it have a absolute scale? And I'm aiming at different resolutions of the phone and stuff.
Well, it's using, in Flutter at least, what it's using is the size of the widget, right? So being a RenderBox, it's got its own size. And then being in its own transform space, the scale is going to be relative to that transform space. So let's say, what can be an example? Well, everything is contained within a certain AABB, which is an axis-aligned bounding box. It's basically a box that surrounds all the objects and currently in view. And that's basically where the scale is computed, right? So the scale is computed in Flare space. That's why also we pass to the controller the view transform matrix, because that way you can get from one transform space to the other. In the space controller demo, for example, moving the object in screen space needed to be computed from the flare space. So you invert a matrix and then you get from one space to the other. But the scale, yeah, it's in flare space. So if you place a widget on screen and you've got a certain size of that widget, the scale is going to be relative to that size.
Okay, thank you.
You're welcome.
Hi, my name is Rive. I'm very new to the Rive app. I just looked it up once, but I got a question to the Xbox looking like controller. It was fully a 3D object, and I just wanted to know in Rive app which component do I have to use, or which tool do I have to use to create a 3D model object?
Well, everything we do is in 2D, but there are some things that you can do to make things look 3D. And the controller in particular was built by one of our animators, so I can get in touch with him maybe and let you know. But since you can deform vertices, you can obtain some pretty believable 3D animations. Also, my first slide, which was the robot, this guy. This has been built by JC Toon instead, and this also gives that faux 3D look. It's still all 2D, but it kind of looks 3D, right? Because it's moving a bit forward and a bit backwards. So I think you might want to talk to our designers if you want to know better how to achieve those looks. But there are some good examples on the Rive website.
Thanks.
You're welcome.
I have a question, so I'm here and at the back, in the back.
Okay, sorry.
You currently rebranded from Flare to Rive, so can we also expect that the class names change?
Absolutely, yeah. We are aware about that. We didn't want to break everything. We didn't want to go from Flare to Rive in all our documentation right away because we feared that a lot of people came to the booth today saying, "What is Rive? Is it similar to Flare?" And it's exactly Flare. It's just now called Rive. And so we still want to go through a smooth transition. It's going to happen at some point. Yeah, it's going to be Rive.
So that means when updating the package, this might come one day.
Yeah, well, we're thinking about smart strategies to do that so that it doesn't kill everybody that's using the package right now.
Thanks.
You're welcome.
Thanks, Umberto. I'm used Rive quite a long. I have experienced that iOS performs quite better than Android. So does those animations on iOS performs better because of Swift runtime used in that, or no?
Well, depends. Did you use the Flare Flutter runtime also on iOS, or were you using our Swift runtime?
Yeah, it's all made in Flutter.
So that's supposedly, we should see the exact example in this case. I think it's either the device or maybe the emulator. It depends on what you're running it onto. Generally, Apple's GPUs are really, really good. So if it's a physical device, we know that iPhones have amazing GPUs and they can perform better. So it's entirely dependent on that. If the runtime is the same, if it's still Flare Flutter, then I don't think that there's anything in the code that's making a difference. It's more a device-related thing.
So under the hood, Flutter doesn't profits in this Swift runtime you have.
What? Sorry,
when I use a Flutter app, it doesn't uses Swift runtime you have.
No. It's all Flutter. It's still using Flutter, so the draw calls are in Flutter. But we do have a Swift runtime which is native to Swift and which runs on iOS and macOS. That's still using Skia. So under the hood, it's still the same engine, but that's a whole different piece of software. And it's still open source. So if you want to take a look at that too, you're absolutely, we're thrilled that you're going to do that, if you're going to do that. So I think we're finished with the time. Thanks a lot for your questions. If you got more, please come here.